take two examples to explain that uh, time series analysis, the additive model and the multiplicative model. Now in this additive model, the question is given a monthly sale of rupees 21,110 explained as follows. That means we are going to use the formula and we are going to prove that we are getting 21,110. Okay, that is our main intention. It is not that we are going to calculate, we are going to prove it. Getting this data, considering this data, using this formula, we are going to get some value and which we are going to match it with this value. Okay, that is our main intention. So in additive model, a monthly sale of rupees 21,110 explained as below. Now think that question is given this one. The trend is given of rupees 20,000. Seasonal factor is given as 1500, okay, or rupees, whatever. The cyclical factor is rupees 800, but this generates a slump of business. So slump of business means it will be negative basically in that case, okay, and expected to depress sales by 800 rupees per month. That means in a month 800 rupees will be a loss for them, okay, for the company. And the residual factor, or we say that random fluctuations, is 410 rupees due to some unpredictable random fluctuations. Let's say that there was a strike, okay, earthquake. Because of that you lost 410 rupees in a month. So these are the data is given and we are using the additive model. And additive model, as per that, T plus C plus S plus R, correct? So T, it is mentioned the trend, which is 20,000 rupees. C is the cyclic factor, which is given 1500 rupees, which you have added. Then we are adding 800 rupees, but this is negative 800 minus 800 because it is going to give a depress in sales, means loss in sales. So I'm writing minus 800, and because of the residual factor, whatever due to unpredictable random fluctuation, you are incurring 410 rupees for that. So this is 410. So total, if you do, it is coming 21,110, which is telling the given figure. So that means as per the additive model, if we apply to this particular problem, we are getting the right value, and that the value is rupees 21,110. Now the same model, if you problem, if I try to use similar problem, if we try to use in additive multiplicative model, then what is this? This is the problem. Okay, the problem is given trend value is 20,000 rupees, seasonal factor is 1.15. okay, a good month for sales because you have got 15% above the trend. It is not the negative. You have got 15% more sales. Okay, 1.15. Cyclical factor is 0.9. Basically it's supposed to be 1, but it has a business slump. So as it is a business slump, instead of giving 10% business slump, instead of giving that, it has given 0.9. That means already slump is calculated. That means 1 minus 10% of slump is nothing but 0.90 value. Okay, and that is the reason we are not going to use the negative form out here. We will be using the positive form. Clear? And residual factor is 1.02. That means there is a random fluctuations plus other two factors are there. Because of that, you got this kind of random fluctuations. So now we are going to use the formula of multiplicative model, and the multiplication model is nothing but y equals to T multiplied by S multiplied by C multiplied by R. The value of T is 20,000. Seasonal factor is nothing but 1.15. Cyclical factor is given 0.90. Again, I'm telling you, I will not use the minus value. It is the plus value because it is given 0.9. If you would have given 10% slump, then we would have given 1 minus 10%, which is 9.9, right? But here in this case, it is already calculated and given 0.9 value. And finally, the residual factor or the random fluctuation factor is nothing but 1.02. If I calculate, multiply it, we are getting 21,114 rupees. Clear? So in the both the cases, we can use this formula, whether it is the additive model or the multiplicative model. Though the questions are different, this question is different and this question is different, but however, you can use any of this model and you can try to find out your expected time analysis value.